Hi, calculus class. Today we are looking at higher order derivatives. So we will be able to differentiate higher order derivatives, including implicit differentiation. Those can get a little bit longer, but we can handle it. So we've been talking about how to find the first derivative, and the first derivative refers to the slope of a curve. We can actually find higher derivatives. You can find the second, the third, the fourth, the fifth. You can keep going and going and going. Now, the second derivative has meaning later on, and actually so does the third derivative, but we'll save that for later. Just know that you can do it for now. So in this table that I have for you, I have different notations on what this looks like. So if we use y, the first derivative is y prime, the second derivative has 2 primes, the third derivative has 3 primes. The nth derivative, you start to just write the number up here, y to the n, or like y to the fourth. You don't want to write out 15 primes or something like that. They kind of look like exponents, so you have to be aware of what's being talked about. Are you talking about an x with an exponent, or are you talking about a function? So just be careful of the notation. It's a little bit different. The f of x notation, you have your f of x, f prime of x, 2 primes, 3 primes. It would be f to the n of x. For example, it would be f to the fourth of x. Doesn't mean f to the fourth power, but it means the fourth derivative. And finally, y, dy dx, d squared y, dx squared. I know those exponents are in different spots. D cubed y over dx cubed. So this would be d to the n y over dx to the n. Just with for notation, it would be d to the fourth y over dx to the fourth. I kind of like the bottom one. There's no confusion about what you're looking for. Is it an exponent? Is it a derivative? That's clearly a derivative, but just be aware of the other ones. Find each of the following derivatives. So when we look at example 1, the first derivative, this is power rule, nothing crazy here, would be 6x to the 5th minus 8x to the 4th plus 10x minus 3. There's your first derivative. So your second derivative, keep going. 30x to the 4th minus 32x cubed plus 10. Then the third derivative would be 120x minus 32 times 3. I got to think about that this morning. 96x squared. The derivative of 10 is 0. And then the derivative of, I goofed somewhere. Oh, I forgot an exponent. That's my third, 120x to the third. There we go. When I keep taking the derivative, 120 times 3 is 360, x squared. 96 times 2 would be 180, and 12, so 192, x. Now, that's the fourth derivative. You could keep going. There's nothing there that says you have to stop in this particular case. So f to the 5th of x would be 720x minus 192. The sixth derivative would be 720. The seventh derivative would be 0. The eighth derivative would be 0. You'll keep going and going and going. If you have a polynomial that only has positive integer exponents, eventually you will hit a 0. If you have negative exponents, well, you've already passed the 0, so they keep getting negative. And if you have fractional exponents, you're going to skip right over that 0. So just a fun little fact there. Find the second derivative of y equals the sine cubed of x. This is looking like a chain rule to me. So if y is equal to the sine of x quantity cubed, the first derivative is 3 sine of x squared. The derivative of sine is cosine. How do you simplify that, rewrite it? We could say 3 cosine of x sine squared of x. Does it matter which one comes first? Nah, not at all. Doesn't matter. All right, so that's the first derivative. The directions are looking for the second derivative. Now, I'm going to scooch over here to the right a little bit. The second derivative now requires a product rule because I have two things being multiplied. So d squared y over dx squared is going to be the first, which is 3 cosine of x, times the derivative of the second, which is sine squared of x, but this is going to be a chain rule again. So 2 sine of x, the derivative of sine is cosine of x. So this is my f, this is my g prime. I'm out of space on my notes, so I'm going to drop this down below. Sorry about that, g f prime. So g is sine squared of x, and f prime is -3 sine of x. Look over that again if you need to. There's a lot going on in this problem. There's a product rule, there is a chain rule, there are trig functions. So just take your time, it's okay. Then I'm going to rewrite this. Oh, when I multiply 3 times 2 gives me 6. I've got 2 cosines, so cosine squared of x, sine of x, minus 3, I can put it up here, 3, sine squared and sine is sine cubed of x. And that, folks, is the derivative. The second derivative, I should say. There you go. So all those rules that we had before, anything that's listed on your golden ticket still applies. So keep working on those. Implicit differentiation. Now, these get a little bit more involved. I'm going to zoom in here because we're going to need some space. Find the second derivative for x squared plus y squared equals 36. So implicit differentiation says the derivative of x squared is 2x plus 2y dy dx is equal to 0. And then we learned we have to solve for dy dx. So 2y dy dx is equal to -2x. dy dx is equal to -2x over 2y. dy dx is equal to -x over y. That's your first derivative. Great job. Now we have to find the second derivative. So d squared y over dx squared. Now I'm looking at a quotient rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom. Now the derivative of y is 1, but it's a y term, so dy dx all over y squared, the bottom squared. That is the calculus step. I'm just going to clean this up a little bit. -y plus x dy dx over y squared. Now, usually when I get to this point in class, I tell a little story. You know, my 5th grade English teacher, Mrs. McGann, the punishment for people misbehaving in class was to write out the definition for the word run from the dictionary. Apparently she said it was the longest definition in the dictionary. I don't know if that was true or not. But in that definition of run, you weren't allowed to use the word run. And I know that's true in your science classes and other classes. When you're defining vocabulary words, you can't use that vocabulary word in the definition. That's kind of what's happening here. We have the second derivative based on the first derivative. So I can't use a derivative in the definition of the derivative. We have to get to x's and y's. And so what we do, I bet some of you see it already, dy dx goes in for dy dx. So we have to substitute. D squared y over dx, oh I forgot my squared up here, squared is -y plus x over y squared, and substitute -x over y. So you have to replace that dy dx notation with the first derivative. Great. Now the algebra teacher in me is not happy because now I have this fraction inside of a fraction. So what do I do with it? Multiply through by your common denominator, this y. Everything else is over 1. So if I multiply by y over y, I have -y squared. In the second piece, the y's cancel out. So I've got -x squared over y cubed. Now, why did that become an arrow? This should be a y. All right. Now the algebra teacher is helping me. We got rid of the fraction side of a fraction, negative y squared minus x squared over y cubed. But there's more. When I look at the numerator, I can factor out a negative sign. Something like this. Does that look familiar at all? Well, yeah, check this out. X squared plus y squared equals 36. X squared plus y squared equals 36. So this is really negative 36 over y cubed. Now, if you get to this point right here, I'm super, super happy. I'm thrilled. You did all of the important calculus stuff. If you get to here, I'm ecstatic. That's above and beyond. Will the original problem always substitute into the second derivative? No, it will not. In this case, it happens to, but that's not always true. What is this shape, by the way? X squared plus y squared equals 36. It's a circle with a radius of 6. So what we've done is we've calculated, this first one is the slope anywhere on that circle. And that second derivative is something called the concavity. We'll get there later. But that first problem doesn't always substitute in. All right, let's try another one here with implicit differentiation. So let's mix up our colors a little bit. Sine of y equals x plus y. So the derivative of the sine of y is going to be the cosine of y dy dx is equal to the derivative of x is 1 and the derivative of y is 1 dy dx. No product rule here, so that's kind of nice. But I do have two different dy dx's, so I need to get those on the same side. I'm going to subtract to the left. Cosine of y dy dx minus 1 dy dx is equal to 1. So I'm going to factor out a dy dx. Cosine of y minus 1 is equal to 1. Dy dx is equal to 1 over cosine of y minus 1. Now, if you had moved your dy dx terms to the right and moved that 1 to the left, you would have the same derivative that I do, but all your signs would be opposite. So you'd have a negative 1 over negative cosine y plus 1. That's okay. As long as all the signs are the same or they're all different, you're fine. So there's our first derivative. Now, to get to the second derivative, instead of working to the right, I'm going to work below. So d squared y over dx squared. What kind of rule do we need here? This one is going to be a quotient rule. So the bottom times the derivative of the top, what's the derivative of 1? That's 0, minus the top times the derivative of the bottom. The derivative of a cosine is negative sine of y dy dx, and the derivative of 1 is 0, all over cosine of y minus 1 quantity squared. Now, I had this conversation with a student earlier. They had asked for a little bit of help. Remember that anything times 0 makes this whole term 0. Not just this piece. This whole piece in the beginning will drop out as well. That's kind of nice. So a negative times a negative is positive sine of y dy dx over cosine of y minus 1 quantity squared. Don't bother foiling out the denominator. Drive yourself crazy. I do see a dy dx. I do want to replace that with the original problem, or the original derivative rather, not the original problem, the original derivative. So dy dx, I see it up here, is 1 over cosine y minus 1. D squared y over dx squared is the sine of y over all of that, cosine of y minus 1 quantity squared. Now, I have this fraction inside of a fraction. I'm going to multiply the top and the bottom by cosine y minus 1. That's how I do it. A few other teachers might look at that a little bit differently, but I look for that denominator. Here it is. So they're going to cancel. I want this. So the derivative is sine of y. Now I have 3 of these cosine y minus 1, so that's kind of handy. Cosine y minus 1 quantity cubed. And that is your second derivative. When I look up above, does it substitute sine of y equals x plus y? You could put an x plus y in the top. Does it do anything for you? Maybe it gives you one less trig function that you have to evaluate, maybe. I would accept either answer in this case. So great job, great job. I'm looking at one more problem over here, and I have seen problems like this on those released AP exams. So let's try something out here. The 101st derivative, no, we're not going to do this 101 times. That's just silly. But the first derivative of sine is cosine. The second derivative, so the derivative of cosine is negative sine. The third derivative of negative sine would be negative cosine. And then the fourth derivative, the derivative of cosine is negative sine, but there's a negative in the front already, so this will be positive sine. And hey, guess what? You're back at the beginning again. So if you found the fifth derivative, the derivative of sine is cosine. So clearly there's a pattern here, and clearly I don't want you to go all the way to 101. You'd be here for an hour. Let's not do that. But you do know about division. So because there are 4 possible derivatives here, you are going to take 101 and divide it by 4. So how many times does 4 go into 101? A little bit of long division, just because we can. 521. Now, somewhere along the way, we told you that that 1 turns into a fraction or a decimal at the end. But before that, you learned it as a remainder 1. So that means that we go through this whole cycle 25 times, but we wind up on remainder 1. You're actually going to wind up right here on your first derivative. There you go. So the 101st derivative of the sine of x will be cosine of x. Yeah, I wrote that wrong. There you go. Great job. Try some of these practice problems. I know when you get to the implicit differentiation, that second derivative, you're going to have questions. I had a conversation with a student the other day. You know, they apologized for asking so many questions. Don't. That's how you're going to be successful in this class. Ask the teacher in the classroom when you're there. Ask over email. Ask over Zoom sessions. If you need a Zoom session with me because it doesn't work out with class times, that's fine. Reach out to me and we'll make it happen. Reach out to Mrs. Oakes. So you got this.